Welcome to the MSJC Internet Authoring Videocast.
In this video, you'll be learning how to complete Review Assignment 11. So in Review Assignment 11, Rebecca has asked us to help with another puzzle page. This page involves solving the Hattori puzzle. The Hattori puzzle is played on a grid of numbers. Each number is either circled or darkened. A darkened cell is referred to as a block. A successful solution will meet these three criteria. The same number cannot be circled more than once in any row or column. Blocks cannot touch horizontally or vertically, though they may be placed diagonally. Circled numbers must complete a continuous path throughout the grid. No circled number or group of circled numbers can be isolated from the others by a line of blocks. So if you look here at the image, this is the solution for puzzle 1. There's actually three puzzles, three different patterns that are possible with this particular game that we're going to be building here. And so if you take a look at that closely, you'll see that all the circles are connected to each other. There's not a place where the blocks, the square, the ones with the black background, the squares with the black background, are not preventing the circles from touching one another. For instance, if I had a row of black blocks, second row here is all black blocks, we'd be isolating this circle in the corner, and that would be illegal. If I had a vertical row of black blocks here underneath of the 3, then we'd be isolating the 1 and the 5 and also this 3, so that would be illegal. So we can actually follow the circles all the way through here. So there is no path that is blocked to be able to start at one circle and then move to all of the other circles. So when you look at the game interface, you can see that we have 3 buttons at the top. This is how the user is going to change from one puzzle to another. And then underneath of those buttons, you can see we have a title that reads Puzzle 1, so that identifies the actual puzzle that they're viewing at this time. And what you'll see is that the circles and the boxes won't be here, the blocks won't be here when we first load the puzzle. There'll just be white squares. It'll be a table full of white squares with the numbers being displayed. And then underneath of that table, you can see we have the difficulty of the puzzle. So this is the easy puzzle, 2 is a medium, and 3 is the difficult. Underneath of the difficulty level, we have 2 other buttons. The check solution button, when the user clicks on that, it'll actually identify to the user whether they have correctly clicked circles or blocks. So if I had this circle here that was number 4, if that was a block, the number would display in red when they click on the check solution button. That would identify that because I have a block there, that's an incorrect marking of that particular cell. Or if I had put a circle where the 3 is up here, then that number 3 would turn red. And it would be on the screen for about a second or so and then disappear. So that's just a way that the user can check to see if they've got the correct solution or not. If they want to actually see the solution, they can just click on this Show Solution button, and it will show them the solution just as we're looking at it right now. So Rebecca wants us to create the interface for the puzzle, similar to what we just saw there in the previous screen. She has already stored the information for the 3 puzzles in a JavaScript file that's named jpf_grids3.js. And within that file, it has the 3 different puzzles. And what we'll see is that for each puzzle, there's going to be a rating, the numbers, and the blocks. So the rating, that's the difficulty level, easy, medium, or difficult. Numbers, that'll actually contain the numbers that will be displayed in each of the table cells in the grid. So when the game starts, there'll be a table, and in each cell there will be a number based on this Hattori, in this case it's puzzle 1, so Hattori 1 numbers. And then there's also an array that is Hattori 1 blocks, and that actually identifies which of the cells should be blocks And so if the cells are not identified as a block, then obviously they should be a circle. So those are the two arrays that we'll be parsing. The numbers array is actually going to be used by the draw Hattori function, which is already completed for us, and that's when it draws out the puzzle initially. But then when we click on that check solution button, it'll check the blocks array against what the user actually has in the puzzle at that time and make a comparison to see if the circles, if the user's identified circles correctly and if they've identified the blocks correctly. So Rebecca has provided us with these functions. So draw Hattori, that actually writes out the HTML code that creates the table and puts together the puzzle for us and displays the numbers within each cell. And then check solution, that's going to return an alert box indicating whether the puzzle has been solved or not. And show solution, which is going to display the puzzle solution. So our job will be to complete the application by writing the code that displays the puzzle, provides the user with an interface to solve it. So on step 1, we're going to open up these two files, JPF Hattori TXT HTML, JPF Hattori TXT.js, put our name and date in there. And then also we want to take a look at this JPF Grids 3 so that you can see these arrays that we were talking about just a bit ago. So here I am in Visual Studio. You can see I've got my RA11 folder open here. We'll double click on the JPF_Hattori text file and the JPF_Hattori text.js file. So go ahead and save that as, remove the _txt, and then in the HTML file we'll do the same thing, just replacing author date information, doing the save as, get rid of the _txt. So in step 2 now we need to go into the HTML file. Directly above the closing head tag, we want to link to the CSS file, the Grids 3 file, and then the one we'll be working in, the JavaScript file we'll be working in, the Hattori.js file. And you want to make sure that you list the Grids 3 before the Hattori.js file because you need all the arrays that are defined in the Grids 3 file to be loaded into memory before the functions that we build in here start looking for those arrays. So before we go into the HTML file, let's take a look at the Grids 3 JavaScript file. And what you're going to see here is basically there's going to be 3 games that have been created. The information for 3 different games, 3 different puzzles, has been created within this file. Each of the puzzles are going to have a rating, numbers, and blocks. So when you look at rating, you can see that the first puzzle is easy. The numbers is an array that, it's a multi-dimensional array that identifies which numbers go into which cells in the table. And then the blocks, that's another multi-dimensional array. And what it's identifying is which of the cells should be circles, those are the ones that are empty, and which of the cells should be blocks, those are the ones that have the hashtag, the pound symbol, the number symbol, whatever you want to call that. So hashtag represents blocks, the empty cells represent the ones that should be circles. So that's how we get the information for each game. So we've got Hattori 1, rating, numbers, and blocks. Then we've got Hattori 2, rating, numbers, and blocks. And then Hattori 3, rating, numbers, and blocks. So those are the variables that we'll be referring to in our JavaScript file to build a puzzle initially, and then also to, when we use the check solution button, to identify whether the user has correctly put the circles in the right cells or the blocks in the right cells. So we'll go to the HTML file now, and right above the closing head tag, we're going to add the link to the JPF_Hattori CSS file, and then we add 2 script tags in here. The first one has the source for grids 3. You want to make sure you load that first, and then the second script has the Hattori.js file, and both are being loaded async. So I'll save that change, but let's now look at the rest of the file here. You'll see in this section element that we have a div that's ID'd as top buttons, and then 3 inputs which are of type button. They're all classed as puzzles, and then each one is identified uniquely: puzzle 1, puzzle 2, puzzle 3, and they also have a value, and the value is what we're going to display to the user depending on which puzzle that they choose to load. Then underneath of that, we've got the puzzle title. So we'll be modifying that again depending on which puzzle the user chooses to load. Then we have this figure element that's been ID'd as puzzle. That's where we'll actually have the puzzle be built into. In the draw Hattori function that's already been built for us does that for us automatically. Then underneath of the puzzle, we've got 2 buttons. So again, we've got a div here. It's ID'd as bottom buttons, and then 2 inputs. Again, they're type button. The first one is ID'd as check. The second one is ID'd as solve, and as you might suspect, then they read check solution and show solution. In step 3 now, we're going to go into the JPF Hattori.js file, and directly below the comment section, we're going to declare a global variable. We're going to call it all cells, and that's what we'll use to store the array of puzzle cells for the Hattori table. So we're just going to create this variable at this time. We're not going to define a value for it yet. So into the Hattori.js file, underneath the comments here, which identify the functions that we're going to be building into this file. And all we're going to do at this point in time, just go ahead and declare a variable, and we're going to name it all cells. In step 4, we're going to insert a command to run the startup function when the page is loaded by the browser. So we haven't built that function yet, but we're just going to set up a call to that function once the window has loaded. So that means when the web browser has completed loading all of the HTML code and everything up in the header section, then it'll go ahead and fire off this startup function. So we use the window.onload function, and we assign to it, and actually that's an event handler, but we're going to assign to it then the name of the function that we want to have called once the window has completed loading, and that'll be the startup function, the one we're going to build here in just a bit. So in step 5, you can see now we're going to add the startup function, and that's going to display the contents of puzzle 1 after the page is loaded, and sets up the initial event handlers for the different buttons that we have. And within the function, we're going to add these commands here. So let's just start by creating the function, then we'll come back one at a time and do the steps underneath of that. So I'm just going to declare the function startup, and put in the open and closing curly braces for the body of that function. Save it, and now we'll do step 5a. So we want to change the inner HTML of the element with the ID of puzzle title, and we're just going to change that text to read puzzle 1. So we just need to use a document.get element by ID, and we're targeting the element that's ID'd as puzzle title, camel cased. We want to change its inner HTML, and we're going to put in the value there of puzzle space 1, and end that statement. And we should be commenting as we go here, so we'll just go ahead and add the comment there, write the first puzzle data into the web page. In fact, also here we should have run the startup function when the browser loads the page. step 5b now, we're going to call the draw Hattori function using the Hattori1 numbers, Hattori1 blocks, and Hattori1 rating variables as the parameter. And that reads kind of odd. I mean, they're just saying we want to identify Hattori1 numbers, Hattori1 blocks, Hattori1 rating. Those are the parameters that we're going to pass into the draw Hattori, so it knows which variables that exist in the grid 3 JavaScript file, which ones were variables we're targeting in that file. And then we want to store the HTML code that's returned by the function, the draw Hattori function, in the inner HTML of the page element, so in the HTML document that has that ID of puzzle. So remember, we had that figure element, it was ID'd as puzzle. So we're going to take the results of calling our draw Hattori function, getting the information for the first puzzle using those 3 variables, and then the results will be stored in the inner HTML of that figure that's ID'd as puzzle. So I just want to point out at the bottom of our Hattori.js file, you'll see that there are some functions already created for us. We've got check solution there, show solution, and then here's the draw Hattori that we're going to be calling here. And you can see it takes 3 parameters, the numbers, the blocks, and the ratings. So we're still working inside of our startup function here. Just add in a new comment that reads display the first puzzle using the Hattori function that we saw down below there. So we use a document.getElementById puzzle. Again, that's the figure. We want to change its inner HTML property. And the way that we're going to do that is we're going to call the draw Hattori function down below and pass to it which of those variables we want it to use. So Hattori1 numbers, Hattori1 blocks, and Hattori1 rating. When the page first loads, we want to load the first puzzle into it and have it displaying to the user. In step 5c, we want to declare the variable puzzle buttons, referencing the page elements that have the class of puzzles. So remember, those are the 3 puzzle buttons, or the 3 buttons, I should say, at the top of the page that were classed as puzzles. And we're just going to loop through the puzzle buttons. There's going to be those 3. And for each button, we want to add an event handler that runs the switch puzzle function when that particular button is clicked. So inside of our startup function, adding a new comment, add event handlers for the puzzle buttons. Here we're creating a variable called puzzle buttons, and then we're going to go ahead and get those puzzle buttons using the document.getElementsByClassName. Remember that when we're getting classes or elements by class name, it's plural there. So get elements by class name, and then we're identifying the class that we're targeting, which is puzzles. So we got the 3 buttons at the top there. Each of them has that class value assigned to them. Then the next part of that step, we needed to parse through that collection now. So this puzzle buttons is a collection of those 3 buttons. So we want to go through each button one at a time. So we create a for loop here. And when we set up the for loop, initially we're going to set var I equal to 0. We want the loop to run as long as I is less than that length of puzzle buttons. So puzzle buttons now has 3 elements in it. That's its length. But you remember how an array works. We start with the first element at 0, and then the second element is 1, and the third element is actually 2. So that's why we're using the less than operator here. Since the puzzle button's length is 3, we want to run this for loop while we're less than 3. So only doing 0, 1, and 2 to grab the 3 buttons one at a time. Of course, we'll increment I by 1 as we go through the for loop. And then we just have a single statement in the for loop here. We're targeting based on the element number now in puzzle button. So remember, I is going to be 0 to begin with. So puzzle button 0, we want to target its on-click event handler and pass to that the switch puzzle function. So in other words, when they click on the button 0, which is the first button at the top of the page, it's going to call switch puzzle. So we go through this loop 3 times, targeting the first button, then increment I, target the second button, increment I, target the third button, each time adding to the on-click handler for each button the switch puzzle, the call to the switch puzzle function. Step 5D now, we want to call the setup puzzle function that defines the initial appearance of the first puzzle. So that just means we're going to call that setup puzzle function. So we're just adding that, again, still in the startup, just after the for loop. Actually, we're missing the closing curly there for the for loop. So we've got a comment that reads, set up the initial appearance of the first puzzle. Then we go ahead and call setup puzzle. And so we'll be building that setup puzzle function here in a little bit. In step 5E, we add an event handler now to the check solutions button to run the find errors function when that button is clicked. And then we'll go ahead while we're here. We'll add the event handler also for the show solutions button. That'll run the show solution function when that button is clicked. So still inside of our startup function, make sure that you're inside of that closing curly brace there. Another comment that reads, add an event handler to the check solution button. You can see that we're getting the button that is ID'd as check using document.getElementById, and then just assigning to its on-click event handler the find errors function. So when we click on that button, that's the function we want to run. And then another comment, add an event handler to the show solution button. We're getting that one by targeting the ID of solve. So document.getElementById solve. That's the solution button. And changing its on-click event handler to have show solution as the function that it will run. Now in step 6, we want to add the switch puzzle function. That switches the page between the 3 different puzzles. And in that, we want to include an event object E as a parameter of the function, and then add the following commands. So when the button is clicked on, there's an event object that gets created that has the information about which button was being clicked. So we're starting a new function. We're going underneath of our startup function, and then creating the switch puzzle function and using E as the parameter we're passing into it. So that's the object that has the information about the button that was actually clicked. So 6A, we want to declare the puzzle ID variable equal to the ID of the event object target. So the actual button that was clicked on will be the ID value. So all we got to do here is just simply create a new variable. We're calling it puzzle ID, and then assigning it the object E's target.id value. So that's the value that gets passed into the puzzle ID. So just to remind you, when we go back to our Hattori HTML file here, that each of those buttons has its own ID. Puzzle 1, Puzzle 2, Puzzle 3. So that's the value now that's being passed into this puzzle ID variable here. 6B, we want to change the inner HTML of the element with the ID puzzle title to be the value of the value attribute of that event object. So 2 things that we need to do here. First, we've got to target the HTML element that we want to modify the inner HTML on. So we do a document.getElementById puzzle title. So we'll take a look at that. That's this H1 element here in the HTML. And then what we're going to do is we're going to pass to it the value of the button that was clicked on. So that's how we get the puzzle name to display here in the H1 element. So we've got the inner HTML of the H1 element, and we're passing to it the object, the button that was clicked on, and its target.value. In step 6C, we're going to create a switch case structure with the puzzle ID variable that loads the appropriate HTML code for each of the 3 puzzles into the page element with the ID of puzzle. So we'll use the draw Hattori function to generate the HTML code and assume that the puzzle ID is limited to the 3 values, puzzle 1, puzzle 2, and puzzle 3. So we're still working inside of the function switch puzzle. So I'm just going right before, I should say, the closing curly brace for that function. Adding now a switch block in here. And the switch block is going to take in the value of puzzle ID that we generated up here. So remember, that's the ID that we actually grabbed from the button that was clicked on. So based on whatever that value is, then one of these three cases will be triggered. So if it was the puzzle 1 button, then it's going to do these two statements here and then break. Or if it's the puzzle 2 button, it'll do these two statements here. Actually, it's one statement, isn't it? Just on, yeah, the assignment is on the second line there. And then break, and then puzzle 3, same thing. So the statement that we're referring to is just document.getElementById puzzle, and then we're changing the inner HTML, and then we're going to assign to it the results of running that drawHattori function and passing to it the 3 variables that we wanted to target in that grid3.js file. So for puzzle 1, we're getting Hattori 1 numbers, Hattori 1 blocks, Hattori 1 rating. For puzzle 2, we're getting Hattori 2 numbers, Hattori 2 blocks, Hattori 2 rating. For puzzle 3, we're getting Hattori 3 numbers, Hattori 3 blocks, Hattori 3 rating, right? So just the particular puzzle based on the button that was clicked on being drawn now into the inner HTML of the ID of puzzle. And just to remind you, the puzzle is that figure right there. That's where the table's going to be built by drawHattori. After the switch case structure, we're going to call the setUpPuzzle function to set up the features of the selected puzzle. So back in our drawHattori, right underneath the curly brace that closes up the switch case, all we're going to do here is just add a comment and then call the setUpPuzzle function. So set up the initial appearance of the puzzle, and then we're calling setUpPuzzle because that's what it does. It goes through, and once the puzzle's been drawn by drawHattori, it goes through and sets up all the properties for each of the cells. So in 6E now, we'll enclose all of the commands in the switchPuzzle function within an if statement that displays a confirm dialog box asking the users whether they want to switch puzzles even though their work has been will be lost. So in other words, if they go and click another button once the puzzle's been drawn, we want to make sure that they are doing that intentionally and didn't click another puzzle number button by mistake. So we'll just have an alert box pop up, say, are you sure you want to do that? And so if the confirm dialog box returns a value of true, then we'll go ahead and run the commands within the if statement. If they click cancel, then it'll be false and their puzzle will not be replaced by a new puzzle. So all of this here is to switch two different puzzles. So it's inside of this, inside of the if statement, that we're going to run those commands if the confirm is going to be true. So we're going to have if confirm, and then we want to pass to the user just a warning that you're going to lose all of your work, and then ask them if they want to continue. So that's the text they'll actually see in the confirm box, and then the confirm box will have a yes no button on it, and if they click yes, then that will be true, then these statements will run. If they click no, then it'll be false and it won't run. So we'll have an open curly brace here. Oops. Open curly for the beginning of the blocks that run, all the statements that we want to have run if the if statement turns out to be true. And then just close that statement, that if block up. So here's the opening of the if, this is the closing of the if. Everything else in between, all those statements, will only run if, when the user sees the confirm box pop up on their screen, if they click yes to make that true. In step 7 now, we're going to set up the setUpPuzzle function to set up the features of the puzzle table. Within the function, we want to add the following commands. So let's just start by creating the function. So just going underneath now of our switchPuzzle function, we'll create a new function. We're going to call it setUpPuzzle. And then inside of there, We'll do step A, which uses the query selector all method to create an object collection of all of the TD elements within the Hattori grid table and save the object collection in the all cells variable. So we're using a query. Well, first we've got a comment, match all of the data cells in the puzzle. Then we're using a query selector all because we're having to have a bit more of a sophisticated, complex selector there. So if you look at it, it's just like the selectors that you set up in a CSS style sheet. So that's why it's called a query selector. And then all means that we're going to get all of the elements that match the selector value that we type in the parentheses there. And then all those cells will be assigned to the all cells variable. Remember, we declared that up here at the very beginning. So it's important we declare that to be able to assign this to all cells here. So all cells then becomes an array of all of the cells within the table. In 7b then, we want to create a for loop that'll loop through that all cells collection. And for each cell, we want to change the background color style to white, the font color to black, the border radius to 0. So we're going to create a for loop here. We've got a comment that says set the initial color of each cell to white, but we're going to open up this for loop, set the variable I to 0. It's going to run as long as we're less than all cells length, so you should understand that by now, and then increment I each time through the loop. We're not going to put the closing curly in just yet because we've got more to go here. I don't like doing that though, actually. I'm going to put my closing curly so I don't forget it. Okay, so the first thing that we do is we target the current cell, change its background color to white, then we target the same cell and change its color using notice we're using the style attribute here. So style dot and then the property, and then making that equal to, assigning it, I should say, the value then of that's being assigned to the property. If this is a style sheet, we do background color colon white, but in JavaScript we're using the assignment operator. So for that same cell, we're assigning the background color to white, we're assigning the color, meaning the foreground color, to black, and setting the border radius to 0. And then we're going through every single cell in the table and doing that. Now the next thing we want to do is 7c, within that same for loop, now we're going to add a mouse down event listener for each of the cells. And using the mouse down event listener, we'll change the cell's appearance depending on whether the shift key, the alt key, or no key is being pressed by the user. So we want to add the following commands to the anonymous function for the mouse down event. So first, change the background color to white, the font color to black, the border radius to 0 if the user is pressing the shift key. Change the background color to black, the font color to white, the border radius to 0 if the user is pressing the alt key. Otherwise, change the background color to this RGB value, which is a gray value, then the font color to white and the border radius to 50. That's how you create a circle. And then to avoid inadvertently selecting the text of the table cells, which the browser would want you to do when you're using a mouse and clicking in a cell, it expects you to select something in the cell. We're going to include a command to prevent the default action of the browser in response to the mouse down event. So remember, we're still working inside of the for loop here. So I'm going to go inside of the closing curly for my for loop. Add this comment, change the color with each mouse down. So we're using the add event listener function. We're assigning to that event listener a mouse down event. So anytime the user presses the mouse button down, we want to check to see, and we're passing to it now the event object. We're checking to see if they're pressing the shift key or the alt key or neither of those keys. So if they're pressing the shift key, then we want to set the object's target style background color. So that's the cell they're clicking on is what the object is here. So that's what the E represents, is the cell they're clicking on. And here we're changing the background color to white. We're changing the foreground color to black, the border radius to 0. So that's the normal state of the cell when the puzzle first loads. If they're holding the Alt key down, we're changing the background color to black, the foreground color to white, and the border radius to 0. So that would be a block that they're creating when they hold the Alt key down. And then the last one, the else here, is if they're not doing a Shift key, they're not doing an Alt key, then it generates a circle. And so the style now, the background color is this gray color, the foreground color is white, and then the border radius is 50%. That's what makes the circle. Now in step 7D, we're being asked to set up the mouse cursor depending on whether the user is pressing the Shift key, the Alt key, or no key. So when the mouse pointer moves over the cell within the for loop, we're going to add a mouse over event listener this time. And for each puzzle cell that runs, the anonymous function actually, I just realized we missed a step up here. We didn't do the prevention of the default browser action. I got to go back and do that. So as I said earlier, when you go to click within a table cell, the web browser wants you to be able to select what's in that cell. We'll add a comment that reads prevent the default action of selecting the table text, and then that's just the object. Remember again, that's the actual table cell, and we're calling its prevent default function, which means that you won't be able to select the text within the cell. Okay, so now we're up to 7D, where we're going to add the mouse over event listener, and in the anonymous function, we're going to change the cursor to JPF eraser PNG with a generic cursor name of alias if they're pressing the Shift key. Otherwise, we'll have the JPF block PNG image with the generic cursor named cell if they're pressing the Alt key. And then if it's neither the Shift key or the Alt key, we're going to add the JPF circle and the generic cursor named pointer. And then finally, within the form loop, we'll just go ahead and add this too. We'll add the event listener that runs the check solution function in response to the mouse up event. So in other words, after the user's clicked into a cell, we want to check to see have they solved the puzzle or not. Okay, so we added the prevent default here. What we need to do though is go ahead and close up that function and then end the statement. You have to remember that this is where the statement begins. Now this is where the statement ends, and in between we've got a function here, and so the function opens with a curly brace and closes with a curly brace. And I just want to position that so that it looks right. So if we collapse our function, you can see that everything inside of that closes. And then this here is the entire add event listener statement. And before the for loop ends and before the function set puzzle ends, so that's these two curlies, that's where we're going to add then our new event listener, the mouse over. So we've got all cells I dot add event listener mouse over. Then we create an anonymous function, and then we're passing into it the object, which again is the actual table cell that the user's clicking on. And again, we're checking to see if they're holding down the Shift key, and if so, we're using the style property to change the cursor to this URL, which is that eraser PNG file, and then also assigning the alias pointer to it. And if they're holding down the Alt key, we're assigning the JPF block PNG and then assigning cell as the pointer. And then finally, we've got if neither the Alt or the Shift key are being held down, we've got the circle image and then pointer as the cursor. So again, we've got the function here, we've got the all cells here, and then after that, we're adding a statement where we add the mouse up event listener, and then that just simply calls the check solution function. Because after the user's clicked on a cell, we want to check to see if they've solved the puzzle. Getting a green squiggly here though still. Why is that? And we should be getting a minimize button here. Oh, I know what it is. I've got a curly brace there instead of a closing parentheses. Yeah, that fixes it. Yeah, you see what I did here when I added the event listener here. See, we've got open parentheses. We identified the event listener and then comma. Instead of putting the name of a function here, we created an anonymous function. And so all of this here is the anonymous function, and that needs to be part of then the values that are being placed inside of this parentheses for the add event listener. And so we want to close it up with the parentheses, and it's just really a single statement. And so we end the statement with a semicolon there. So that's the same thing that we did here, just it was a little bit shorter. Okay, step 7E now. For the for loop, add the event listener, it runs check solution. We did that already. So we're up to step 8. We want to create the find errors function that will highlight incorrect cells by displaying the cell number of an incorrect cell in a red font. So let's start the function. So all of this right here is actually our setup puzzle function. That's where these collapse buttons come in handy. So I just collapse that. Go ahead and create our find errors function. Open curly and then close curly. And so step 8A, we're going to create a for loop that goes through all the cells in the all cells object collection. If the cell belongs to the blocks class but has a background color of gray, or if it belongs to the circle class but has a black background, we're going to change the font color to red because that either of those situations would be incorrect. So we create a for loop, doing our var I, setting it to 0. We're going to run it as long as we're less than the all cells length, increment I each time through. Then we do an if check to see if all cells class name is blocks and all cells style background color, the gray. Remember, blocks has a black background color. So if that's true, or, so here's the or operator here. So this is a long expression in the if statement we're checking. Or if the all cells class name is circles and the all cells style background color is black, so circles background is gray, that would be incorrect. So if all of that resolves to true, so if it's either block and gray or circles and black, then we want to change the font color to red because that indicates an error. Then we want the red font color to appear only briefly after the for loop, so we're going to set up a set timeout method and assign to it a 1-second interval, and then within the set timeout method we'll add an anonymous function that then loops through every cell in the all cells collection and just changes the cell with the font color of red back to white. So going just after the for loop, we had a comment here, remove the hints after 1 second. So there's the set timeout method inside of there and anonymous function. And for the anonymous function, we got a comment that reads change all cells with red font back to white. So the for loop now is just going through all the cells, checking to see if its color is red. And if the color is red, then we go ahead and assign the color to white. So back to the way it was originally. And we're going to run that every second. Step 9 is just having us document our code. So we jump over to step 10 now. Save the changes to our file. We'll load up our JPF Hattori HTML in the browser. And then we want to verify that we can switch to the different puzzles. We want to verify that we can change a cell to a gray circle by clicking the cell. Verify that we can change the cell to a solid black block by clicking the cell with the Alt button pressed down. And then finally restore a cell black text on white background by clicking a previously selected cell with the Shift key down. We also want to verify the cursor changes the shape as we move the mouse pointer over the puzzle cells, changing from a circular cursor to a block cursor when the Alt is pressed, or the eraser cursor when the Shift key is pressed. Verify that we can test the errors by clicking on the Check Solution button, and that the errors are displayed in the red font for 1 second. And solve the first puzzle using the solution provided in figure 1151. Verify that we can receive a congratulatory message upon successful completing of the puzzle. Okay, so back in Visual Studio, I'm going to right-click on my Hattori.html file and view it in the browser. So there we can see we have puzzle 1 loaded. We've got the ability to change puzzles. Here's the confirm box asking us OK or cancel. So OK gives a true, cancel is a false. OK allows us to change to a different puzzle. Okay, so then we'll go ahead and just see if show solution works. So there's the actual solution. We'll reset it. We want to see now if we get the circle as we go over the white cells. If I hold the Shift key down, it changes to an eraser. If I hold the Alt key down, it changes to a black square. Now I'm just going to go ahead and do the solution here, and let's just change this to a circle. So now it's not correct. So now we'll click on Check Solution, and you can see for 1 second that one did change to a red text color. So we want to go back to a block. So I'll hold down the Alt key, click on that, make it a block. It appears to all be working. So that's it for Review Assignment 11. Until next time, happy coding. If you liked this video, please click the like button and leave us a comment down below. I also would appreciate it if you would subscribe to our YouTube channel. Also, click the notification bell so that you'll be notified when new videos are posted.